Hello, everyone, and welcome to our webcast today. We're going to get started with our multi-component assembly design in Fusion 360 with Jennifer McMillan. So Jennifer, I'll hand things over to you.
Great, everyone. Thank you so much for joining me today. As Karine mentioned, my name is Jennifer McMillan. I'm the Instructional Design Project Manager with ASCENT, and basically what I do at ASCENT is I manage a group of SMEs, and we all work to create new training guides as well as update existing ones, and we work with partners as well to write curriculum for the Autodesk suite of products. Myself personally, I'm a mechanical engineer, and I focus on the mechanical side of things, so Inventor is where I spend most of my time, but as of late, Fusion 360 has been where I've been focusing, and with that, we released a new training guide just earlier in the spring. So focus today is going to be dealing with Fusion 360, and I'm going to focus on the multi-component modeling side of that software product. So kind of creating and putting all of your designs together to create that assembled product. So in terms of the training class today, the webcast, it'll be about an hour. I'm going to be focusing on the content from that new training guide that we released. It's called Autodesk Fusion 360 Introduction to Parametric Modeling. And the two chapters that I'm going to be kind of focusing content on are distributed design and multi-body design. And these are two of the methods that Fusion 360 enables you to kind of use to create that assembled design. So I will be taking questions at the end of the presentation, so absolutely if you have any questions, please put them in the chat window and we'll deal with that. Presentation is going to be PowerPoint-based as well as mostly spending time in Fusion 360 doing demonstrations. And the demonstrations that I'm going to be doing are exercises that are used in the two chapters in this training guide. So to get started, I want to explain one of the methods. So we're going to start with the distributed design method of creating that multi-component design using Fusion 360. So one of the funny things when I started looking at this, you know, I'm coming from Inventor and I use the word assembly all the time. And with Fusion 360, Autodesk has really gotten away from using the word assembly. So they have used basically the term design. So you are simply creating a design, whether it's a single component design or whether it's a multi-component design. So that's, I'm going to try my hardest, but you know, old habits are hard to break as we go through here. I will be using the word, I'm sure, assembly throughout, off and on, but the focus will be on creating that multi-component design. So we're going to look at the first method, which is distributed design. And what this method does is it basically takes your previously created designs, so those single part files, and then combines them all by inserting them into a top-level design file. So basically you're referencing everything. So this is done in Inventor, it's done in other CAD packages, so it's basically that linking or inserting of files that already exist. So in terms of the steps for kind of bringing this together, you create a new design file, and what you need to do before you can even insert your first component is you have to save it. So you're prompted for that if you start and you don't realize, because a lot of packages don't require that first save, it will prompt you that it has to be saved. And then you go in and you simply locate the component in your data panel. Now, one of the big things that's different with Fusion 360 is the use of Autodesk 360 to store all your data. So all of the data is actually stored on the cloud, and you access that cloud system to store all the data. And as you're inserting, you're basically navigating this data panel to find the files you need, and you create, you know, folder structures and all that stuff. So it's similar to it being local, but it's actually in the cloud. And that's all done through this data panel. So you locate your file on the data panel, and then you simply insert it. And you can see here in this image, I've got an example here of pulling in one of the parts. I'm just inserting it into the current design. As in the next step, what you're going to do is you're going to place that component in the assembly. There I go with assembly. So in the design, So what you do here is you're simply placing it, and immediately as soon as it's brought in, it's going to bring up the move palette as well as the triad that appears directly on the model. And I love this triad. It's so convenient. It's easy to use. It's really free form in terms of just grabbing and dragging and moving and that type of thing. So you are able to use kind of either option if you have exact values to move to, or you can just pull and translate and rotate with the triad. In this situation, I'm actually placing my first component. So like in any kind of assembled product, you want to ground something. So I'm just going to cancel, like when it's my first component, I'd cancel this move operation, and I would go instead and actually ground the file. So I'd go and right-click in the browser and ground it. And once it's grounded, then it's locked and it's constrained in the design. So with this distributed design method, you've inserted a file because you're actually going to be seeing this kind of this chain link that gets added to the model browser. So it's a little icon that gets added adjacent to the file name. So you can see it here in the right-hand image. And then you simply continue to insert and place your components. So I'm going back to my data panel, I'm finding more components, and I'm bringing them in. And you're placing them and moving them in position. And when it actually comes in immediately, it's coming in aligned with the default coordinate system. So oftentimes, it's just overlaying everything over top of one another. So this is where that move comes in really handy. I tend to use it to move it kind of into a convenient location for my constraint step that's next. And I'll even rotate it in order so that I can see the faces that I'm going to need to select when I go to constrain it. So you can see I've added a couple components here, 2 different components in, and one of them is still activated. That it's just in the move tool. And then you move to constraining the component, just like it's showing here. So with Fusion 360, the constraints are used, they're constrained using joints. So you have this inventor as well, but in Inventor you also have the ability to use constraints like mate and align. That is not possible in Fusion. That's all done using joints. And the joints are defined using joint origin. So once I get into the actual demonstration, it'll make a lot more sense. But basically know that you're selecting references, a single reference on each component, which is a joint origin. And then you're deciding on what type of origin, which type of joint you actually want to create. And by choosing that type, you're actually defining the motion that's going to be available. So each of these types, and I have them expanded out here on the right-hand side, that are available allow for certain degrees of freedom. So, rigid, it would constrain in all 3 degrees of freedom. Revolute would constrain in all 3 translational and 2 rotational, leaving it open to rotate, et cetera, et cetera. So these terms are all very standard in any tool that uses joints, any kind of analysis tool as well. A lot of them use these types of things. So it is consistent with those types of things. And then you can go in and further customize it by changing your alignment, your angle and your offset, which axes it's actually going to leave open if it's a slider in this case. So you basically can do all of your constraining using this joint palette. One other thing that is really great and nice about the Fusion 360 product is that it actually has access directly to the McMaster CAR content library. So this is a content library that many users would go to purchase reusable items that are used over and over again, fasteners, bolts, nuts, all those types of things. So this library is actually given direct access right inside of Fusion 360. So I can select basically an insert command, and it would bring me to this website, and I can navigate through. And it actually has access to CAD files, so I can then insert that CAD file into my model. So very handy, and I will also show you this in the demonstration that's coming up now. So I'm going to flip back over into Fusion now, and I'm going to create kind of this wheel assembly here, and you're going to see some of the components are created, and those fasteners are going to be pulled from that library. So Fusion. So if you haven't seen Fusion, it's here it is on the screen now, and the first thing I want to draw your attention to is this data panel. So I mentioned it briefly, where it is allowing you and providing you basically that window through to the Autodesk 360 account where the files are stored. There's a whole directory structure. There's kind of projects where you can create a project, and then within that project you have all of your files and your folders, that kind of thing. So in this one, I've created basically a project which is my webcast today, and then I had folder structures developed underneath it, which is presentation files, and this one, the wheel assembly. So I've just activated that right now to get started with. When you launch Fusion 360, it immediately opens a untitled file and a design file. So I'm just going to use this one to create my assembled design. So I'd mentioned that when I try and insert, so if I was going to insert here, it gives me a warning down here that I have to save the design. So no problem, I can do that. I can click wheel, just enter something here. And as soon as it's saving, it is taking a little bit of time here. And the reason why is it's saving to my Autodesk 360 account in the cloud. That doesn't stop me from working. I can start inserting stuff now. So I'm going to right-click on the plate, which is what I want to start with. And you can see that it has brought in my plate. And the Move palette is immediately activated. And I can use this to move around and do whatever I want. So as I mentioned, I'm going to ground this, so I don't really need to do any kind of moving at this point. I'm going to click Cancel. And you can see that my plate is positioned here. I'm just going to right-click on it and ground it. Okay. And like Inventor, you get the little push pin on the solid icon that indicates that this is the grounded component. So I've assembled my or inserted, I should say, my first component into my design. Now I'm going to go out and I'm going to do the same thing with the bracket. So I could right-click and insert if I want, but I can also just drag and drop. So you can see that it's dragged in. Now, I mentioned that it inserts it directly into, kind of aligns it with the coordinate system. So this is where Move becomes very helpful. So I'm just going to drag this out here. I'm going to rotate it using the rotate handle. I don't care about the exact value, so that's why I'm just kind of pushing and pulling and not worrying so much, because I just want to make it easy for me to assign my joint in a second. And now I'm good with everything. I'm going to select OK. Now you can see if I try and move my plate, it doesn't move, and that's because it's grounded. With the bracket, though, I can move it. So you can see that it's definitely not constrained. Up in the ribbon, I can select Revert here, and that's just going to move it back into the position that it was. To add your joint, you want to go to the Assemble pull-down menu, and I can select Joint, and the Joint palette comes up. And what happens here is you need to pick your two references. Now, right now, because the plate is grounded, I can't select the reference for component 1 on that design because it can't be moved. So component 1 is always the component that moves into position. So right now, I need to move my plate in, or sorry, my bracket. If I drag my mouse around, you can see that I'm seeing lots of little joint origins. So these little things are being snapped to faces. They can snap to edges, snap to the center of a cylinder, the middle of a cylinder, the center of a edge, that type of thing. So what's key here is that you're actually picking the right joint origin. And one little trick, and something I really like, is pressing and holding the Control key. So right now, if I move just slightly, you can see I'm moving from the edge to the, so I could easily pick the wrong reference. If I press the hold the Control key, it locks in the selection to that edge. So now I can drag my mouse around, and you can see it's actually only ever moving between the endpoints and the midpoints. So it's a nice tool to use. So I'm going to select this midpoint of the edge on my component 1. It now flips to component 2, and now that plate's available. So I can select a reference on there. So again, I can find the edge. That's that edge there. I'm going to press and hold Control to be sure that I'm getting the right reference. and it will move into position. So by default, it's picking rigid. It basically defaults to the last selection, so I just rebooted the system, so rigid is the first one. And then this is this little animate button, which is quite handy because it tells you it gives you a little visual cue as to what's happening. So you can see that that little shaking is locking it in place. It's rigid. It's removing all degrees of freedom. So then I can select OK. I don't need to offset. Everything looks perfect. I now have my first joint added, and it's now constrained my bracket. So I can try and select it and drag it, and it's not going to move. I want to add another bracket here. And another option, instead of dragging out from my palette, I could go in here and copy and then paste it. So it's the exact same thing. I'm just creating a copy of it. I'm going to use move again. The move tool turns up right away. I'm going to move this out of the way. I want to be able to see the bottom surface, so I'm just going to do some rotates here and move that there, and then I can click OK. So I've now got it in a new position. And again, I need to go in and add a joint. And I want to select, this time I'm just to show you something different. I'm going to actually show you that I can pick the center point of a face as well. So you can see that it would pick all the boundaries of it. So I want the center point of this face. And I'm going to join it with the center point of this face. They're both joint origins that I'm selecting. So it's put those two joint origins together, just happen to put them together not quite as I want. So I can use triad, so I could drag it into position, or I could just go over and modify the value. So I know it's going to be 180, and move that into position. You know, sometimes they flip. So you can use the flip key the flip button there to do that as well. And I can select OK. So now I have got my 3 components in my design, and everything is all joined together to fully constrain it. The next component that I'm going to add is my axle. Drag that in from my data panel. Move it out of the way just to give it a little bit more easy to see. And I'm going to add my joint. Now this one is a bit different because, and I'll explain this, actually I'm going to do one thing first. I need to do a measurement on my, my design here. So I need to know the distance between those 2 brackets. So I'm going to hit measure and pick this surface. And one thing that that took me a bit to figure out, so I definitely want to give you guys a tip here. In Inventor, if you hover over a hidden surface, it will automatically bring up the Select Other tool so that I could pick that hidden surface. With Fusion 360, you have to hover over it, but then you have to press and hold the left mouse button. So I've just done that, and then I can scroll down and scroll through and pick that inner face. So now that hidden face is selected, and if I look over in my measure tool, it's showing that it's 57 millimeters between the 2 faces. So I'm going to need that in a second when I do my assembly, so I wanted to get that value. I'm going to add another joint, and this time I'm going to join and move the axle into position, so that's got to be my very first component. So I'm going to select the center of the cylinder. So you can see here there's the joint origin. It's highlighted. I'm going to select that. Now, as you can see, there's no joint origin between these 2 faces, and there is actually no way to create one between those 2 faces because joint origins can exist only on individual design components. So what I have to do is I'm going to select the center of that edge. So you can see that joint origin is active. I'm going to move that in position. I'm going to flip this to front to show you what's happened here. So basically it's moved and aligned those 2 joint origins. However, that's not exactly where I want it, and that's where that distance mattered. So I can enter 28.5 now as my offset, and you can see it's gone in the wrong direction, so I'm going to have to enter just a negative value. And you can see now it's positioning it where I want to. With this, I'm going to change this. Instead of rigid, I'm going to use a revolute joint type. And you can see that if I hit the play button here, the icon associated with that joint is spinning, so you can see that it is moving. It's moving the way I want it. One thing I just want to flip here to show you is the rotation axes. So the Revolute type removes all of translational, but allows for one rotational movement, and you can actually define which rotational movement that is. By default, it defaults here to Z, so I lucked out, but if you ever had to change that, you could go in and pick which axes you want to allow it to rotate in. Okay, as you can see that those are all completely wrong, but we want to leave it with the Z axes and give us the rotation we want. So we can click OK here, and we have our assembled components. So just a break from assembling there, I just want to review the model browser. All of these joints that we've just created are all listed in the joints folder here, so you can see I've expanded it. You can go in and rename it, and this is something I really recommend because just looking at the names don't make much sense in terms of what they pertain to. So I'm going to just rename that axle just to make it clear. I'm not going to waste time right now renaming the other two, but it's always a good thing to do. And you can see on the model that it's actually giving us these icons that show the type of joint that's been added. Some people may like working with that because it gives them that confidence that the constraint has been added. However, once you're ensured that everything is added and everything's good, you may want to turn those off. So you can go in and turn off those icons as well. So that's just by selecting on the light bulb. So I've turned those on and off, or you can do it globally with the icon for the actual joint folder. I'll leave those off for now. I don't really need them. Thinking back now, I actually don't want that axle to move, right? I want the wheel to move. So what I'm going to do is I'm going to make a modification here. So in the timeline at the bottom, so this is recording all of the actions that we've done. And if you work through that, you can see the different icons. So this is a component insert. This is another component insert for the bracket. This is where we grounded it, the bracket, or sorry, the plate, and then where we've added the other joints. So you can see that each one of those have a unique icon being added to the timeline. I can right-click on that last one, which is currently the Revolute joint, and I'm just going to go in and make that change and change it back to rigid. So now we're good, and it's time to put in the wheel. So I'm going to just drag the wheel in. And you can see that I can just leave that there. It's no problem. I can add my joint. This is a really good example of where holding that control key down when selecting your joint origins is really important, because I need to pick one that's in the hidden surface here. So it's down. I want to pick the central joint origin, and to get to it, it's not going to allow me to do that. So holding that control key down locks it to that surface, and I can go down into the model to pick that center joint origin. And I also want to assign it to the axle, the center origin there. And if I turn to front, you can see that that didn't position properly. So as I mentioned, that joint palette, it retains a memory of previous values. So it's maintained that offset that I used when I joined the axle. So I just had to change that to 0, and everything's great. I know that my Revolute is perfect. I'm just going to click OK, and we're good to go. So now I have that assembled. So lastly, what I want to do is show you that McMaster car, how we can access that. So if you go into the Insert panel, I can select Insert McMaster car component, and that's going to bring me out into the into the website, and I can then navigate through here. So it's a lot of navigation. You kind of have to select what you want. Let's say I want the head cap screws. I can narrow it down as well over here by size, so it will only show you the sizes that you want. Let's see, I'm just going to choose here. And I'll choose this. Let's say I want the fully threaded versions of those models. Sounds great. And then over on the right-hand side, it actually starts to put the list of files in here. So had I not narrowed it down, this list would be quite large. And and then I can simply select one of them. So let's select this first one here. And basically the first prompt is like, okay, great, you can buy this product, so you can enter and purchase anything, add to your order, that kind of thing. But what I want to focus on is this product detail. So you want to select product detail. This is basically giving you access to the CAD file. And if you scroll down, you can see there's this nice little drawing with all the dimensions of that cap screw. But what I want to do is I want to download the 3D step file and click Save. And basically, this is then going to insert the file directly into my multi-component design. And you can see here that it can do that. And it brings it in. I moved it a little bit so I can select my references. I could go in there and move it. So with this, I am going to be capturing the motion. So I moved that component. And this is just something that happens here. I can capture that position just to leave it there temporarily. We can delete that motion afterwards. It's just something that gets added to the timeline. I won't need that motion because I'm actually going to be constraining it. I've got my joint palette open. I select my joint origin on the cap screw and the joint origin on my bracket. And you can see it moves into position. So here's an example of where I would have to flip my component using that flip button. I'm just going to actually set it as rigid because that's its final position, and click OK. And you can see how that's assembled. So I could continue to go back to that McMaster car library, find washers, find nuts, that type of thing, and bring them all in. And you can see how it's added it to the model browser. And I have it listed over here as the actual part number, and it's inserted. If you look over in the data panel, though, you'll notice that that file is actually not been added, right? So it only inserted it into my design. And you can tell that also by the fact that there's no chain link there. So this is just an inserted component. Okay, so it's all stored within. I personally find that I like to go to that McMaster car library outside. So just going through Windows Explorer and navigating there and then downloading all the files locally and then uploading them to my Autodesk Fusion 360 account. So if you're constantly using the same fasteners, it definitely saves a lot of time. So you can create that library of the fasteners that you use on your Fusion 360 account, or sorry, Autodesk 360 account, and just go to them and insert them as you need them. It just saves a little bit of navigation as you're designing. So at this point, I'm just going to leave this design. I'm not going to fill in the rest of the components. What you would do to duplicate them, you'd probably right-click and do your copy and paste, or you could go and insert more, whichever you feel comfortable doing. Most efficient is definitely copy and paste. So this is the distributed design method, distributed being that it's pulling all of the files from other separate design files and bringing them all together in one design. I'm going to flip back to the PowerPoint presentation and continue on to show you the multi-body design. So this is the second method that Fusion uses to create that multi-component design within Fusion 360. This method enables you to create your components that are going to form that assembled product all within the one design file. You basically start with a single body, and then you start adding additional bodies all within the context of the same design, so you can reference existing faces, existing edges, all that type of thing. So you're building all that logic based on the existing design, that's the geometry that's already in the model. And once you've created all those bodies, then you have to convert those bodies to components. And once they're components, then you'd go in and you'd add your joints to constrain everything. One additional tool that becomes available to you when you're using this multi-body design and constraining everything is something called an as-built joint. And this is quite nice because it actually takes into consideration the way that you've built the model initially. So generally, if you're building two components that mate with one another, you've selected one as the sketch plane, and the two bodies are actually touching already. So it knows with the as-built joint that those two are touching, and will assign the joint that way, and you don't have to go in and actually pick the joint origins, which is kind of nice. With either method, you can actually work a little of both. So in this image that I show here, it's kind of an easel stand, just a collapsible easel stand that's been designed in Fusion 360. And you can see here, there's a bunch of components with the chain link icon associated with them, which means that they were inserted. And those, in fact, if you kind of recognize the numbers, those were all the McMaster car library components, all those fasteners that actually hold this together. Yet everything else, so the easel, legs, and canvas support, all of those things were actually built using the multi-body design. So they're referencing all of the different geometries of the components to create more components. So that's what the multi-body design functionality allows for. So now I want to, again, flip over to Fusion and give you a presentation on that. Now, I mentioned in the design or the data panel that I have a directory structure. So my last demo was with the wheel assembly. So I'm going to go out to my presentation files here, and I have a second folder with what I want to start with here. So I have a single model in here, so I'm going to open this model into Fusion 360. I think you can right-click open as well. I just double-clicked. And you can see that I currently have a single body that exists, and this is representing the valve, kind of the starting point for my model. So what I want to do is rename this because it makes much more sense to make it noticeable and recognizable in terms of what you want to call things. So to start with then, I simply need to create a second body. So I'm going to go in and create a new sketch. I'm going to create the end cap to this valve. So I'm going to select the sketch plane. And when I do that, it actually projects the edges that are on that plane. So I'm going to, at this point, just stop the sketch because I have what I need. And I can create my extrude. So I select the extrude, which is available on the Create menu, extrude, or it's generally the default on the Create panel. And I can select what I want to extrude. So I'm going to extrude those two things. And I'm going to drag it out about 20 millimeters, and you can see how it's created that. Now, so the extrude panel is over here, and this is what's key with the multi-body design method, is by default, the operation right now is set to join. So what that means is it's basically going to join that geometry to the existing body. I don't want that. I actually want to create a brand new body. So I'm going to expand that menu and select New Body, and I can select OK. And you can see now that I actually have a second body that's been added to my model. So there are two separate bodies right now. The second body being the end cap, reference the sketch plane and the edges. So it really built a lot of logic into that model. The next thing I want to do is I realize, okay, so at this point I think I've missed the gasket. I probably should have put a gasket in between those two. So I just wanted to show you some of the tools that you can use to do that. I'm going to actually just turn off the display of that model for a second, and I'm going to go in and create an offset plane. From this plane, I'm going to just move that out about 2 millimeters. If I turn this to the right, you can see that construction plane appears just 2 millimeters offset from the end cap, the end of the valve. And I can turn on the end cap again, okay? Now, if you think about your feature order and the timeline, you have your extrude and then you have your construction plane. I actually need my construction plane to be before the extrude to use some of my tools to create that gasket. So I just dragged it, so it's a simple drag along the timeline to move it before the extrude. Now what I can use is one of the multi-body tools. I can go in and split the body. So this is one of the multi-body tools that's available. You can split bodies or combine bodies. In this situation, I need to split a body. The body I want to split is this end cap. And the splitting tool I'm going to use was that construction plane that I selected. And then if I select OK, you can now see, I'm going to turn off the construction plane. You can now see that I have 3 bodies. You can see the difference in the geometry there. I'm going to rename this one to gasket. And the last one there is just end cap. So I have my 3 bodies. Okay. So those are 3 bodies that I've created using the multi-body design. They all reference each other. Next thing I need is a fastener. So I could go out and grab something from the McMaster car environment. Right now what I want to do is I actually want to create it in context just to show you a few things. So I'm going to create a sketch as well on this outside plane. I am going to stop the sketch because right now I have what I need projected. I'm going to create an extrude. I'm going to extrude that feature just through, just drag it to a 155 works for me. And at this point again, I want to draw your attention to the extrude palette, and you can see it defaults to join. So you always have to be sure that you're moving to, new body. But what I want to highlight here is this new component option. So I mentioned in the presentation that one of the steps in this process is you create all your bodies and then you have to convert them to components. With Extrude, you can actually create the component immediately. So I'm going to do that. I'm going to create a new component here for this situation. I could have done it in the other cases as well. I'm just going to show you something different here. And I'm going to select OK. So you can see now the difference is those 3 will be, those would-be components that are going to be converted are listed in the body folder, but this component is actually out at the top level. So I'm just going to rename that to bolt. And now I have a component. Now I need to add the head of that bolt. So to do that, what I have to be sure to do is activate that component to work in it. So I'm going to roll my mouse over it and select this little activate component button. And you can see now that the stem of the bolt is blue, it's active, and the rest of everything is gray. So now what I can do is I can go in and create my sketch on this plane, go in and just add a little bit of geometry here, not adding any dimensions or anything, but of course that all can be done. I'm going to create my extrude. I'm going to extrude out the cap. And in this situation, in the extrude panel, I do want to keep the joint tool because I'm joining the 2 bodies of the bolt to create, the one component. And there we have it. So I have the bolt created. To activate the top level assembly again, I just go up to Valve and select Activate Component, and you can see that everything now becomes blue. So I've now created that. Okay. In terms of next steps here, creating additional bolts, joints, all that type of thing, you definitely have to go through and do all that. So I could start off first, actually, sorry, I skipped one major step here is the conversion. So the valve, I need to convert that to a body. So valve, right-click, create components from bodies. Perfect. Super easy. It actually keeps the name of the body as well, so I don't have to do anything. And I can convert all 3 of them. So now you can see that I have a 4-component model. And if you notice too, none of the chain link icons are there because I'm using that multi-body design method. I'm creating them all in context of the top level design. I'm going to need some more bolts. So I could go in and do a copy and do a paste. Great, I could drag that out here just to give me some access to the easy picks. And I didn't add the joints everywhere else, but not yet anyway. I'm going to use the joint command for this one, so I'm going to pick that origin center and the origin center here, and you can see that it locks into position. Now, I had mentioned that as-built joint functionality, and this is where it's pretty awesome because you can go in here and select as-built joint, and for instance, with this component, the first bolt and the end cap, you can see that all I need to do is select 2 components, and it immediately assigns the rigid constraint, and it immediately keeps the references exactly where they were built, so everything looks great there. I can continue to do the same thing as built joint between this and this, the gasket and the valve. And then with the valve, I actually need to ground that component. So I can go in and ground it. So now if I actually pick this, nothing is going to move. Everything is locked down. I want to show you, so I can continue to add, do the copy and paste functionality, but one other functionality that I find really convenient here is the pattern. So I'm going to go in here and I'm going to create a rectangular pattern to duplicate these two bolts. I'm going to pattern components, so I select that pattern type, select my two bolts. I know that my direction is going to be in this axis. I'm going to select that as the option. I'm going to pattern 2 copies of it. I happen to know that the distance between those holes is 25.4 millimeters. You can see here that, again, the negative is wrong, so I'm just going to enter a minus 25.4. And now I have my full 4 bolts. So I would go on and I would I could use the as-built joint type there to bring those and hold those in position. If you think of other steps here, I could go back to the back of this model and create washers. So I could do that all by using sketching planes and building that washer out and a nut as well. Or I could use the insert tool to bring in any washers and nuts from the McMaster CAD Library. So you can see that with Fusion 360, you kind of have the flexibility of doing the multi-component design, or you can do the insert if you have components already existing and that are reusable within your company. So that's what I wanted to show you today. The 2 methods that we talked about, again, distributed design and multi-body design. Just to finish things up here, I mentioned that I manage the manufacturing side of all of our curriculum. I know some of you on the line are with our ATCs and are always interested in what we've got released already this year. So I've just kind of highlighted this all, and it's always available on our website if you ever needed to look at it. So you can see our electrical books are out. Mechanical will be out in September. Lots of inventor books out. iLogic's coming within the next couple weeks. And then the rest of the books there, which are all of our simulation titles, have all been released for 2017 as well. So lots of mold flow titles, some of which actually had been Autodesk hadn't updated in a couple years. So I know that a couple of our customers were really excited about that. And one of the new titles on this list, excited to have now, we worked with Autodesk to create a CFD book. So that is something new to us as well as new to Autodesk, a CFD training guide for new users of that product. So I mentioned this training guide, and one of the things that's really unique about it is that we did a little bit of a different layout in terms of this Fusion 360 book. We worked with our partners at 4D Technologies to utilize their CAD Learning product. So what we've done is we have a little bit different formats that this is available in. We have our standard ebooks, and in that ebook it actually accesses videos, these CAD Learning videos, to explain the topics within Fusion. So if there's no video, there's more written content, bit where videos aren't used. We also make it available in an e-course format, so again, it would just be, you'd be able to play those videos. And the next one, in which something we're really excited about, is that this book is available in print on Amazon. So you can actually go to Amazon's website and purchase this book. And what's really nice about this is with that purchase, if you send to us, there's information in the book, proof of purchase, you actually get access to that e-course that we have as well, so that you can access all of those online videos. So some great ways to access all the content and to purchase this training guide. All available, the 2 ebooks, the ebook and the e-course, available on our e-store. We've had some great feedback. Lots of people are really liking it. The big thing, of course, is people loving watching videos versus reading content. It's quite nice. So hopefully that format will appeal to you guys. And with that, I'm going to hand it back over to Corrine, and we'll close up and we'll answer some questions.
Great, wonderful. Thank you, Jennifer. So I just wanted to draw everyone's attention to this last slide, just so you know how to reach us. We've got our ASCENT e-store up there. Plus, we've got our website, which is the ASCENTED.com website there on the bottom. It says beside blog. But if you go to the website, actually, it's probably your best bet because you can get all of the courseware information for all of our books there. So you can download a table of contents, a sample chapter, and basically have a look at the book before you buy. And then from the website, you can choose whether you don't want to buy on Amazon, because we do have several of our titles on Amazon now as well, or you can go through the ASCENT e-store and purchase. It's up to you. And we're on social media, so we have a blog, we're on Twitter and on LinkedIn, so we do invite you to join us. And of course, if you have any questions or if you have any comments, especially about this book, as Jennifer said, we love to take people's feedback into consideration when we're updating our courseware. You can email us at feedback@ascented.com.